All right, Java Week 1. Got an exam or a quiz breathing down your neck? Don't worry, you've come to the right place. This is your crash course, your high-speed review to absolutely nail the fundamentals. So, here's the game plan. We're going to tackle 5 key areas. We'll start with Java's core features, then peek under the hood at its execution model. After that, we'll dissect a basic program, cover the essential data types, and wrap it all up with operators. Let's get right into it. First things first, what's the big deal with Java anyway? Why has it been a powerhouse for decades? Let's break down exactly what makes it so special. Okay, listen up, because if you only remember one concept, this is it. Platform independence. This isn't just another feature. It's Java's superpower, its entire philosophy. I can pretty much guarantee you will see this on your exam, so let's lock it in.
So what does that actually mean? Well, think about the old days with languages like C++. You were basically a software chef, right? You'd have to compile a separate version of your program for Windows, another for Mac, and yet another for Linux. It was a ton of work. Java just completely flipped the script with this beautiful, simple mantra: write once, run anywhere.
Now, beyond that killer feature, you need these 4 buzzwords committed to memory. Think of them as your exam cheat sheet. Java is object-oriented, which is a huge paradigm shift. It's robust, meaning it's designed to be tough and not crash easily. It's secure, which is a big reason it took over the early internet. And, believe it or not, it's considered simple, mainly because it ditched some of the really tricky error-prone stuff from C++.
Okay, so that run anywhere promise sounds great, maybe a little like magic. But how does Java actually pull it off? Well, it's not magic, it's just some seriously clever engineering. So let's pull back the curtain and see how it works. Yeah, seriously, think about that for a second. How can one single file, one compiled program just work on completely different operating systems? The secret lies in a special intermediate step, and you absolutely have to understand this for any technical test. And here it is, the whole journey from your code to a running application. You write your source code in a .java file. Then, the compiler, Javac, does its thing. But here's the twist. It doesn't create machine code for Windows or Mac. Nope, it creates this universal, platform-neutral thing called bytecode. Then, the Java Virtual Machine, or JVM, acts like a real-time translator on whatever device it's on. The JVM is the bridge that makes it all possible. So what exactly is this bytecode stuff? The best way to think of it is as a universal language. It's not machine code for a specific computer. It's a special language made for the Java Virtual Machine. So any device on the planet that has a JVM installed, your server, your laptop, your phone, can understand and execute this bytecode. It's the lingua franca of the Java world. All right, so we get how a program runs. Now let's look at what a program actually is. We're going to break down the basic anatomy, the essential blueprint that every single Java application is built on. Ah, yes, the classic hello world. Every programmer's first step. For your exam, you need to look at this code and instantly spot the 3 crucial parts. First, the class definition. Think of that as the container for your whole program. Inside that, you've got the main method. That is the front door. It's where the JVM starts running your code. And finally, you have the actual statement that does the work. In this case, printing to the screen. Now, pay close attention, because these are the simple rules that trip everyone up, which means they are perfect for exam questions. Rule number 1, Java is case sensitive. System with a capital S and system with a lowercase s are 2 completely different things. Rule 2, the file name must match the public class name. Exactly. And rule 3, the program always starts running inside that specific main method. That's your entry point, period. Moving on. To do anything interesting, our programs need to store information. Numbers, text, true or false values. In Java, the most basic units for storing this data are called primitive data types. And here they are. This table right here is pure gold for studying. You have got to know these 8 primitive types. You've got Boolean for true or false, char for single characters, and then a whole family of types for numbers, right? Different sizes for whole numbers, byte, short, int, long, and 2 for numbers with decimal points, float, and double. Go ahead and commit these to memory. Now, here's a key distinction that you've got to remember.
Why are they called primitive? It's because they just hold a simple, raw value. That's it. An int holds a number. A Boolean holds true or false. They aren't complex objects that have special abilities or behaviors. They are the simple, foundational building blocks of your program.
Okay, last big topic for week 1. We have our data, but how do we actually do stuff with it? That's where operators come in. You can think of them as the verbs of the Java language. They let us add, compare, and manipulate all our data. For your exam, it's really helpful to know the main families of operators. You've got your arithmetic operators for all your basic math. You've got relational operators for comparing things. Is this equal to that? Is it greater than? Logical operators for combining true-false conditions, and of course, assignment operators for storing values in your variables. Just being able to categorize them is half the battle. This is so important. Remember PEMDAS from math class? Well, Java has its own strict set of rules for which operation happens first, called operator precedence. And this is a sneaky one, because if you get it wrong, your code won't crash, it'll just give you the wrong answer, which can be even worse and much harder to track down. So how do you avoid messing this up? Well, you could try to memorize the entire complicated precedence table, or you could do what every smart programmer does. When in doubt, use parentheses. Parentheses are your best friend. They override the default rules, they force the order you want, and they make your code 1,000 times easier to read. It's the safest bet for your code and for your exam. All right, let's do a super quick recap of the absolute must-knows. 1. Java's superpower is platform independence, thanks to the JVM and bytecode. 2. Every program lives in a class and kicks off in the main method. 3. You need to know those 8 primitive data types. And 4. Operator precedence is key, but parentheses are your secret weapon to control it. Nail these concepts, and you're in great shape. So with these fundamentals locked in, you're not just learning rules anymore. You're ready to start thinking like a programmer and actually solving problems. So think about it for a second. What's the first problem, big or small, that you would tackle with this? Good luck with your exams.